Children, good morning once again. Next article, magnetic line, magnetic dipole moment of a revolving electron. We know that figure, we know that electron is moving around the nucleus. It is nucleus and E is the electron. And distance between that, it is a small r. Children, an electron revolving in an orbit about the nucleus of an atom is a minute current loop and produces a magnetic field surrounded it. It thus behaves like a magnetic dipole. Let us calculate the magnetic moment. Here, Me is the mass and E is the electronic charge. Electronic charge and small v the speed. Okay, children, therefore I equal to E upon t, because q equal to q equal to it equal to ne. Therefore I equal to E upon T, where if n is equal to 1 electron, that is number of electron is 1, therefore value will be E upon T. Okay, children, where T is the time period of revolution. We know that formula of T equal to 2 pi r upon V. Children, we know that the formula of V equal to R omega. So children, omega is equal to angular velocity and V is equal to linear velocity. That is, if body moves in a straight line, then it represents linear velocity. If motion in circular motion, that is the angular velocity. V equal to R omega is the relation between the V and R and omega. Children, omega is equal to 2 pi n, where n is equal to frequency, r 2 pi, n is equal to 1 upon t. V equal to 2 pi r into 1 upon t. Therefore, children, t equal to 2 pi r V upon 2 pi r upon V. Okay, children, if the putting the value of capital T in above equation of current, then value will be I equal to EV upon 2 pi r. Children, it is the current. If A is the area, is equal to pi r square, the area of the current loop electron orbit is equal to A equal to pi r square. Then find out the value of small m by the help of I and A. Children, m equal to IA, that is value of I is EV upon 2 pi r and area is the pi r square. Okay, children, pi cancel, r only one cancel, that EV is equal to m equal to EV r upon 2. Okay, children, please see this picture. Electron is revolving around the nucleus and m magnetic moment, m is the magnetic moment and j is the angular momentum and v is the velocity, r is the radius, e is the electron. Okay, we know that the current is clockwise by the help of right hand rule. The dipole moment m vector is the perpendicular to the plane of the current loop direct downwards as shown in this figure. The magnitude of the orbital angular momentum j vector is of the revolving electron is given by j equal to MEV/r, where g is the angular momentum, m is the mass of the electron, v is the velocity, r is the radius. On comparing magnetic moment and angular momentum. Okay children, so we know that m is equal to EV r upon 2 and j equal to MEV r. Equation number 1 and 2. On dividing first by 2, we get m upon g is equal to EVR upon 2 MEVR, that VR cancel, that is E upon 2 ME, E upon 2 ME. This ratio represents the magnitude of the magnetic dipole moment to the magnetic magnitude of the angular momentum of the revolving electron is a constant, independent of the details of the orbit. This ratio is called as the gyromagnetic ratio. It is the very important point, gyromagnetic ratio. Beta, gyromagnetic ratio. Okay children, therefore m vector equal to E upon 2 ME d vector, which is represented in the vector form. Okay children, good day.